All right, welcome back. Today we are diving deep into a concept that is, and I mean this, absolutely essential if you're building B2B software. We're talking about multi-tenancy. It's the secret sauce that lets you serve hundreds, even thousands of customers from one single application. But here's the thing, if you get it wrong, you are in for a world of hurt.
So let's just start with a really important question. Imagine your app is a huge success. You've got hundreds of different companies using it every single day. Now pause and think about that. They are all logged into the same system. How can you be 100% sure that their data is completely, totally walled off from each other? The stakes on this are just massive.
And that really brings us to what we call the shared app dilemma. Look, this is not just some feature you can check off a list. It's probably the single biggest architectural risk you're going to face building a SaaS product. One tiny mistake, and the consequences could be absolutely devastating. So what exactly is multi-tenancy? Honestly, it's just a fancy word for an architecture where lots of different clients, we call them tenants, all share one single running instance of your app. The best way to think about it is like an apartment building. You've got one building, right? But inside there are dozens of separate locked apartments. Our job as the architects is to build walls that are rock solid and install locks that are literally impossible to pick.
The number one rule here is incredibly simple, and it's totally non-negotiable. An employee from Company A must never, under any circumstances, see the data of Company B. I'm talking no invoices, no user lists, no secret projects, nothing. No exceptions. It is the absolute bedrock of trust in B2B software.
And this is exactly why we cannot leave this to chance. I mean, think about it. If your whole security model relies on every single developer remembering to manually add a where tenant ID equals ? Clause to every database query they ever write, well, it's not a question of if a mistake will happen, it's when. And that one forgotten line of code could be fatal to your business. We need a system that's automated and completely foolproof.
Okay, so how do we build this foolproof system? Well, it turns out there are basically three main paths you can go down, and each one comes with its own set of pros and cons. Let's really dig in and see how they stack up against each other.
Now this right here, this is where it gets really interesting. You've got options. Okay, so first up, you could give every single tenant their own separate database. As you can see, that gives you the highest possible level of isolation. It's physical separation. Awesome, right? But then look at the cost and maintenance. It's a total nightmare, both operationally and financially. Okay, so then you could use different schemas inside one database. That's a decent middle ground, but notice that key challenge. When you get to a large scale, database migrations become a huge pain. And then there's the boldest move, a single schema where everybody shares the same tables. It's the cheapest, the most efficient, but as you can see, it requires that your application code is absolutely airtight.
So, which path are we going to explore today? You guessed it, we're going with the single schema solution. Now, I know what you might be thinking. Whoa, that sounds like the riskiest option by far, and you're not wrong. But with your particularly clever pattern, we can make it not only scalable and maintainable, but also unbelievably secure.
And here's why this is such a smart choice for the long run. It's all about health and scalability. You completely sidestep the operational nightmare of managing thousands of databases, and updates become so much simpler because you're only ever changing one single database structure. This approach is built for growth, plain and simple.
Now, the secret to pulling this off is this amazing three-part combo. These three patterns work together in perfect sync. First, we use a special header in the web request to figure out which company the user belongs to. Then, we stash that company ID in a temporary little box, a context, that only exists for that single request. And finally, part three, this is where the magic happens. We use a database filter that automatically and invisibly applies that ID to every single query. It's beautiful.
Okay, theory is one thing, but let's actually see how this works in the real world. We're going to follow a single API request on its journey right from the user's browser all the way to our database and back again. And you'll see exactly how this system guarantees that data never, ever leaks.
It all kicks off right here. A user clicks a button in your app. Their browser sends a request to your server. But this isn't just any old request. Tucked inside is a custom HTTP header that acts kind of like a digital keycard, telling our system exactly which tenant, which company, this request belongs to.
And look how simple it is on the surface. That's it. It's just a key-value pair, something like xTenant ID, Acme Corp. This one little line of text is the starting gun for our entire security process. So the instant that request hits our back end, a filter grabs it before any of our business logic even gets a chance to run. It plucks that Acme Corp ID right out of the header and sticks it into a special temporary storage space. Now, this space is thread safe, which basically means it's a private little box that only this one request can ever access. This is crucial for preventing data from bleeding between two different users who are using the app at the exact same time.
And in the actual code, it looks as simple as this. From this point forward, this tenant context holder is the one and only source of truth for who this user is for the entire, very short life of this request.
All right, so the request continues on its journey. And now our code needs to get some data from the database. Well, just before that happens, another bit of automation kicks in. It's something called an aspect. You can think of it like a little gatekeeper that's always watching. It sees we're about to talk to the database and boom, it flips the switch.
This is literally that switch being flipped. It tells our database session, hey, listen up. For everything you do from this moment on, you must use this thing called the tenant filter. And then it grabs that tenant ID we safely stored a moment ago and hands it directly to that filter.
And this is the beautiful part. This is the payoff. Now a developer writes some nice, simple, clean code to say, fetch all employees. They don't have to think about tenants. They don't have to worry about security. But behind the scenes, our database tool, Hibernate, sees our filters active and it automatically, invisibly, adds the correct where clause for them every single time.
I mean, just look at this transformation. The developer writes the clean, simple code on the left, but what the database actually runs is the rock-solid, completely secure SQL on the right. This happens for every read, every update, every delete. It's totally, completely foolproof. The developer can't forget it, even if they tried. But hold on, we're not done yet. There is one last step, and it is absolutely critical. Once all our work is finished and the response is flying back to the user's browser, we have to clean up after ourselves. We have to remove that tenant ID from our little context box.
And this is totally non-negotiable. Why? Well, modern web servers are super efficient. They reuse processing threads for different users to save resources. If we didn't clear out that context, the very next user to get assigned this thread could accidentally inherit the identity of Acme Corp and see all of their data. That would be a catastrophe. This finally block is the safety net that absolutely prevents that disaster from ever happening.
So there you have it. We've built a really elegant and secure system using this single schema approach. It's incredibly powerful. But like any big engineering decision, it's not a silver bullet. It comes with trade-offs. So let's take an honest look at what we've gained and what we've given up.
Let's circle back to that big decision we made earlier. Remember that database per tenant model, the expensive one? Its biggest selling point is for really strict compliance standards like HIPAA, which sometimes require actual physical data separation. Our single schema model might not pass those kinds of specific audits. But here's the flip side. Trying to manage thousands of separate database connections can literally crash your application, whereas our approach uses one standard, super efficient connection pool that can scale almost indefinitely.
So, we have built this incredibly elegant system for making sure tenant data stays separate. It's automatic, it's safe, but it all hinges on one little piece of information we've been taking on faith this whole time, that X tenant ID header. How do we really know that the user sending a request for Acme Corp is actually an employee of Acme Corp and is allowed to see that data? Well, that's a question of authorization, and that is a whole other story for our next explainer.